Hello, my name is Rajendra Chima. I'm responsible for marketing and application for high performance BU within Business Group 2. Thanks for giving me the opportunity to show what we do here. Today, I'm going to demo the serial technology offering from Socionext. So here, first, we have multiple demos that we're going to show. If you look at in terms of a networking, compute, and storage, all the interfaces are going serial. For example, SCSI was a parallel move to SAS. Similarly, PCI was a parallel interface move to PCI Express, which is a serial interface. So here we are showing at the high end of this. This is our 28 nanometer, 28 gig SerDes. So this is the test chip with the 2x4 macros. This is the power supply board where we get the power supply regulated, plus the reference clock comes into this board. On this test chip, we have two by 4 lane macros on both sides. So here we're demoing connecting 3 lanes from one macro to the 3 lanes of the other macro. Due to the limitation of the cable, we are not connecting the 4th lane. So here you see the lanes from one macro comes in, goes to the paddle card, through the backplane, come back. Total insertion loss of this is about 35 dB. So it's running at 25 gig, about 35 dB. So this is the FCI standard compliance board, backplane board. So here is we are running actual software on that or seeing actual data. Here you can see these are 4 lanes, lane 0, 1, 2, and 3. All of these lanes are actually loop back, external loop back through the backplane and the cable. Total loss again, as we said earlier, is about 35 dB. So all of these lanes, as you can see, is running error free. Now to ensure that they are really error free, we can disable transmit. So receiver should start showing an error. So I disable it, see an error. I enable it, error is frozen, means no more error. I clear it, no more error. So you can see similarly on the lane 1 also, I did the same thing. I see an error, I enabled it, error is frozen, and then I clear it. I don't see any more error. Now some of those things in a high speed SerDes is kind of how do you do the equalization? Here we're showing on the transmitter side, we can pick any lane. Here we're showing only lane 1. So what are the equalization we have? We have a precursor, main, and a postcursor. So these are different values that can be programmed manually or can be programmed through the link training. Here on the receiver side, we have a multi-stage CTLE. So you can see that's getting adapted, and DFE followed by the other equalization parameters here. Here you can see it's adapting on its own, and you can see the values changing as it goes along. So that is our 28 nanometer, 28 gig long reach SerDes. This is actually a 16 nanometer long reach SerDes with a lot more equalization as compared to the 28 nanometer. Right now, we're actually working with our development team in Japan. So the power supply board is not here, so we cannot demo it today. Maybe next time we can do it. So now let's move from 28 gig, 25, 28 gig to 56 gig. So here we are. This is our test chip that was done in 28 nanometer. It has 3 lanes of 56 gig NRZ and 1 lane of 56 gig PAM4. And we are looping back 56 gig NRZ through the cable. We have a lane that's looped back, and you can see it's an NRZ 56 gig. It's external loop back running PRBS 31 error free. The total loss on the board package and the cable is about 16 dB. So here you can see, again, as we did earlier, to confirm that it's running error free, I'm going to disable TX, and I should see an error. As you can see here, the errors are moving. Now I again enable TX, error count is frozen, so I clear it, it's running no error. On this side, we are actually running PAM4. So here you can see this is the PAM4i that we are transmitting. So this is 56.2 gig PAM4. So these are kind of 3 different eyes. If you look at the PAM4 is coded, so you have 4 stages. So this is the eyes for that. So here we are transmitting data. This is actually PRBS 7. We actually de-embedded a channel, so it's not at the ball. It's actually the ball, not at the output of the cable. We have a non-destructive eye monitor in our demos here. So here I can actually go to the eye monitor part of it, and here we have, since we have 4 channels, we can run eye monitor on all 4 of those channels. So here I'm going to run this when I'm running, and actually we're going to see the eye on all the 4. So this is very helpful to debug in the field when customer has a silicon, they have an issue. So we can run this and look at the data, what's really received internally, and is there an issue with that? And if there is an issue, how to solve that? This is a very helpful tool. And this is non-destructive. It can be run during the customer's normal operation. And thank you.